Hi, hello everyone. After a long time, welcome back again. I am happy to be here with you through this webinar, Sedimentology and Reservoir Geology, provided by PNA Academy. I especially want highly welcome our instructor today, Dr. Ali Sayed. We are very happy that you are joining us through this session. My name is Salma Hadi, a petroleum geologist, and I am the moderator of this session in behalf of PetroNile Academy. For those who don't know, Dr. Ali has a long experience in oil industry, about 18 years and above. He holding a PhD in sedimentology and reservoir geology from the German University, Berlin Technical University. He also worked as a part-timer in many Sudanese university, Bahri, Khartoum, and Nilan University. In 2011, he worked as a manager for petroleum data center, and he worked as a senior development geologist at Apex Reservoir Services Company, Beijing, 2013. He worked as a head of Geology Labs department since 2030 to 2019. Finally, he worked at Schlumberger FMI Images Unit Sudan office during 211. And finally, he worked as a technical consultant at NCLC Sudan office 2010. Just a quick reminder for everyone, please write down all your comment in the chat box. And okay, let us welcome Dr. Ali. So without any further ado, the mic is yours, Dr. Ali. You can start.
Thanks, DNA Academy, for this chance to introduce. My topic is sedimentology and reservoir geology of the Cretaceous strata in Sudan interior reef basins. We will focus on a study case, especially in Higlet oil fields, that is in a Muglad reef basin. The objectives of the study, the current studies concern with the following: characterize the sedimentary facies and the depositional value environments, besides establishing a facies depositional model for the studied strata, which can be used as a tool in directing the future exploration work. 2, to investigate the basin's evolution, intensity of value weathering, sediment transportation process, depositional history, and source rock origin. 3, to infer the effect of the depositional regime and the diagenetic process on the reservoir rock quality of the study area. Let us speak about the regional geology. How did these reef basins come to the nature? That is the tectonic and structural framework. The central and southern Sudan interior reef basins began to develop in the late Jurassic time to early Cretaceous. In the late Jurassic time, a triple junction began to develop along the Kenya coastline separating Malagasy Island. The failed arm of this triple junction extended from Lumio in Yemen through the Anza Trough in Kenya and into the South Sudan. At the same time, that is during the late Jurassic, and to the west, the African and South America cratons began to separate. That is the separation of Latin America from Africa, give rise to this shearing along the Central Africa shear zone, creating these subparallel basins. Due to these major events, a shear reactivation along the Central Africa shear zone developed, which led to the development of parallel and subparallel harp crabbing of predominantly northwest-southeast orientation in central and southern Sudan cratonic areas. This showing the map showing separation of Africa and South America continents give rise to this reef basin. Also here in the map, you can see the reef basins in the central and western Africa due to this Central African shear zone that create these rifts. Here also another map to see the Central Africa Shear Zone and the rift basins, especially this south of this Central African Shear line. And this is tectonically controlled. The Muglad Basin, as you know, is the main petrophilous sedimentary basin in Sudan, and it represents the western flank of the South Interior Rift Basins, which are a part of Central Africa Rift System. We take one example, a big oil field to be studied. It lies, that is, Iglig, in the southeastern part of this basin. But the basin, which is about 300 kilometers wide and more than 1,200 kilometers long, is predominantly, this is the Muglad Basin, is predominantly trending northwest southeast. The basin is bounded by the longitudes 26 and 30 degrees east and latitudes 8 to 12 north degrees. Here is the location of the study area. Rifting in Sudan started in the late Jurassic, as I said, up to middle Miocene. The tectonic development of the Muglad Basin, if we focus on the Muglad Basin, we have three rifting phases. We have a pre-rifting phase, three rifting phases, and each rifting phase followed by a sack phase. This gives rise to thickness up to 3 cycles. The thickness of them is up to 13 kilometers. All of them are non-marine siliciclastic sediments. That is, the least stratigraphic unit of the Muglad Basin consists of 3 items: the Precambrian basement complex at the base, then we have the 3 cycles, late Jurassic to early Cretaceous, tertiary strata, and then discovered by the tertiary quaternary sediments of Imbrowaba Formation. This represents a generalized stratigraphical column of the Muglad Basin. We have the 3 cycles. The first cycle starts from, in the past we said that this is Sharif Formation, but now we call all of this Abu Jabra, and then covered by Bantio Formation. And this the cycle ends by deposition of Bantio. And then start the new rifting phase, giving rise to the second cycles of sediments, Darfur group, Aradeba Zarga, Ghazal Baraka Formation. And then the last cycles start by Nile Tendi, Adok. We call these 3 formations Kordofan group. Also, this show the value deposition environments generalized for this basin. These value deposition environments mainly range from lake lacustrine, freshwater, then feeds by meandering and braided river fluvial, and then at the periphery of the lake we will find the deltaic deposition environments. In this study, the subsurface of the middle to upper Cretaceous sediment strata is investigated by 7 sedimentological techniques, which are subsurface facies analysis, which is based on cutting sample and 7 conventional core description analysis, as well as interpretation of oil logs and seismic sections. Also, we did petrographic analysis to investigate the reservoir quality of these rocks, of these reservoir target rocks. Also, we did chemomineralogy using X-ray diffraction analysis. Also, we did inorganic geochemical analysis to confirm the paleodeposition environment with these inorganic elements. The subsurface facies analysis reveals that we have 9 lithofacies types. 9 lithofacies types. All of them are, as I said, siliciclastic. We haven't got any marine environment here, marine sediments here. Based on analysis and interpretation of oil logs, core cuttings, seismic section, the studied formation uh, that is Bantu, Abu Jabra Bantu, and Aradeva Zerga Ghazal formation are classified into 3 depositional units of Ferris order. These 3 depositional unit sequences, as I said, dominantly at the base we have the lacustrine dominated unit, more or less in the middle of the profiles of the well, deltaic, and then that is as the periphery of the basin. But within this, we have fluvial dominated units. Here, you have lateral correlation of the studied wells showing Bantu, Aradeva, and Zerga formation. We give the wells here X1, X2. This is due to the confidentiality of the data. And X3, this is 3 wells. That is the lateral correlation of the Bantu, Aradeva, across Bantu, Aradeva, and Zerga formation to show you that is the main 3 depositional units. As I said, we have a lacustrine, then we have fluvial dominated unit, then we have deltaic. Also, this is another 3 wells, lateral correlation of Bantu, Aradeva, and Zerga. Bantu is mainly braided river. Aradeva at the base, we have deltaic. Then the Aradeva ended by meandering river, finding upward. Then also Zerga, the same as Aradeva. But Ghazal, we have more or less braided to meandering rivers. The seismic analysis give rise, we take some sections across the Muglad Basin. We found that the maximum thickness of the sediments in the most part of the study area reached about 6,000 meters in thickness. And also we have 3 seismic facies reflection pattern. We have divergent pattern, parallel to subparallel. We have formic climaform pattern. And each pattern give rise to, for example, the divergent pattern give rise to indicate the differential subsidence rates. The parallel and subparallel pattern indicate uniform rates of deposition. And the formic climaform indicate the lobes of the deltas. That is, we have deltas within this deposition area. Of course, all of this sedimentation controlled by the Lysofacies association of the study area was controlled by allocyclic and autocyclic control. That is, factors within the basin and factors outside the basin, which include tectonic influence, of course, and paleoclimatic events, as well as depositional mechanisms. This is one of the seismic section across the strike of the Muglad Basin, showing the divergent patterns. This is also another seismic section, and it is cross-section interpretation. Give rise, you can see the formic climaform indicating deltaic deposition environments, especially in Aradeva and Zerga formation. Also here you have another seismic sections across the strike of across Muglad Basin. Also we did petrography. In the petrography, we found that all of these sandstone belonging to subarcosic class. We make also model analysis and the study of this sandstone that and indicate that they stem, all of the sediment stem generally from a continental province, transitional between the stable interior of a craton and a basin uplift. This allows the detrital component to be recycled and deposited for rather long distance and to be deposited in extensional and a pull-apart basin. That is, the basin, the Muglad Basin is a pull-apart basin. The reservoir quality of Bantu and Aradeva is better than that of Zerga formation. However, the reservoir quality of this formation was affected positively and negatively by several diagenetic processes, as we will see. This is triangles show the sandstone samples that have been taken from core samples, indicating that all of this sandstone belonging to subarcosic group. Here, using the thin section under the microscope, you can see the diagenetic process. You can see carbonate precipitation. You can see quartz overgrowth, dissolution of carbonate, dissolution of feldspar. That is, if you did dissolution of feldspar, dissolution of carbonate, we have more or less a small, minor carbonate cement because, as I said, it is syncliclastic sediments. The solution of feldspar and carbonate give rise to new secondary porosity, which increase the reservoir quality. But the carbonate precipitation, that is siderite and calcite in minor amounts, give rise to lowering the porosity, lowering the permeability of the reservoir, lowering the reservoir quality. Here also you can see the quartz overgrowth. Quartz overgrowth give rise to, it is more or less lowering the porosity because it deposited within and around the quartz, the detrital quartz grain, making these pores, fill these pores and give rise to few porosities. Also, you have here diagenesis, also the solution of feldspar in Aradeba. That one is in Bantu. And also here you can see also in Aradeba formation, the solution of hydrocarbon throughout the study. Also, we did SEM, that is a scanning through microscope, to see inside the pore. You can see here, you see we have precipitation of kaolinite inside the pore. This blocking the pore. Also, we have illite due to the lower strata. We have due to increase of pressure and temperature, transforming this smectite to be illite. That is illite crystallinity, illitization. And this illite will block the pore, reducing the porosity, reducing the permeability, and hindering the flow of the oil. Here also you can see the smectite precipitation and oxygenic smectite filling the pore, bridging the pores and lining the pores. Also here you have a chloride, another clay mineral also within the pores. Also we did clay mineralogy, as I said, and we found that we can subdivide the study strata, that is Bantu, Aradeba, and Zerga, into 3 clay mineral zones. We have the lower clay mineral zone characterized by high kaolinite and high illite, high amount. The middle clay mineral zone characterized by high amount of smectite. The upper characterized by high value of kaolinite. What this means? This indicates that these in the lower clay mineral zone, that is, we have high value of smectite, suggests that the warm humid climate was interrupted by dry period. This is in the middle. In the lower, we have increase of kaolinite. This is indicate we have much water. And then we have also high amount of illite. This illite came diagenetically, formed diagenetically, because we have this illite after precipitation formed, and this affect the, as I said, the permeability. The upper clay mineral zone also we have high amount of kaolinite, indicate hot, wet condition. But the middle we have a smectite, suggests that this warm, humid climate was interrupted sometimes by dry periods. This is from the clay mineralogy. Also, we did inorganic geochemistry, revealed professional enrichment and depletion of certain elements. We have the less mobile elements and the more mobile elements. The less mobile elements, that is titanium, gallium chrome, and zirconium occur in higher amount in the proximal facies, that is in the fluvial channels as well as in the deltaic mouth part. Whereas the more mobile elements, magnesium, calcium, potassium, or rubidium, occur in higher amounts in where? In the distal facies, that is in lacustrine, in the deltaic distal part, and the floodplains of the rivers. So at the proximal side, at the proximal facies, we have much of the less mobile elements. In the distal part, we have the more mobile elements. So we can depict, we can make a map for this proximal facies and for this distal facies. This is show the vertical distribution of the clay mineral in wells, as well as the major and trace elements coexist with this clay mineral. Also, in another well, also you can see in the middle you can see the smectite concentration, the middle zone. Also here in the middle zone, you can see the smectite content increase. In the lower zone, you have kaolinite. The upper zone also you'll have kaolinite. That is the vertical distribution of the clay mineralogy in this area. Let us to conclude my topic. All of the lithofacies type of the studied area belonging to silky-clastic sediments, and the belly deposition environments ranges from fluvial dominated to lacustrine dominated and deltaic dominated, starting by lacustrine dominated, then fluvial dominated, and at the periphery we will find this deltaic dominated. The sandstone of the study area are subarcosic, that is the feldspar range between component range between 13 to 22%. And the stem, that is the sediment stem generated from a continental province, as I said, transitional between the stable interior of craton and a basement uplift. That is indicate that the Muglad Reef Basin is a pull apart basin. The reservoir quality of the Bantu and Aradeba in general better than that of Zarqa. Moreover, the reservoir quality of the study sandstone was affected, as I said, positively and negatively. Positively effect give rise to increase the porosity, secondary porosity. Negatively blocking the pores. This is affecting the reservoir quality by several, which include mechanical compaction as overburden pressure, grain slippage, and crushing of the ductile grains. We have quasi-pore growth, precipitation of siderite and calcite, precipitation of feldspar, and clay mineral osteogenesis. Also, we have the solution of carbonate and feldspar. This gives rise to increase the porosity. The amount of the heavy mineral, we also did heavy mineral analysis. We find some zones. We have 3 mineral zones. We make this is against the textural maturity of the sediments. Textural maturity here is the heavy mineral. You see, here is the heavy mineral. We have a diagram showing the textural maturity against the concentration of the heavy mineral. Whenever you have zircon tourmaline rutile increase, this means that the source origin of the sediment is granitic to granodioritic sediment. And then, because this is hard minerals, tolerance to the weathering, when you find a high concentration, meaning that the sediment is supported to strong reworking effect. When you have less, this means that the sediments is more or less immature. We make ZTR index against sillimanite evidot hornblende index. This is along the wells of the studied wells, showing the vertical distribution of ZTR index and sillimanite evidot hornblende, indicating the textural maturity of the sediments of these three basins, of these three formations. Here also in the other three wells, diagram of zircon, tourmaline, rutile, and selimanite epidote indices which with the sediments maturity indicating as the studied intervals. Wherever you have IZTR means mature to overmature. Wherever you have selimanite epidote hornblende, this is immature sediments. To conclude my topic, as I said, all of the lithofacies type of this can be classified into three different units of ferrous order. We have alluvial dominated unit, lacustrine, and the take. The sandstone are more or less subarcosic. The reservoir quality of one river is better than Zarga. The amount of heavy minerals, kyanite and garnet, silverside, those of zircon tourmaline. This indicates a metamorphic source rock origin of granitic to granodioritic composition. Three heavy mineral assembly zone with greater lateral and vertical continuity were identified. That is ZR, zircon, rutile, selimanite, epidote hornblende, and kyanite underlying zone. Four major textural maturity level, as I said, which are immature, moderately mature, mature, and overmature were identified. 3 to 2 clay mineral zone, as I said, can be noticed, but with different percentage. The lower and the upper clay mineral zones contain higher value of kaolinite in comparison to the middle clay mineral zone, which contain a relatively high value of smectite in comparison to the lower and the upper. The higher amount of kaolinite indicate what? Indicate that the lower and the upper zone suggests intensive chemical weathering and leaching process under warm, humid climate, much water. Moreover, the market presence of smectite indicate what? Indicate that the warm, humid climate was interrupted by dry season. The lower clay mineral zone shows an increase of light. This is due to the diagenetic process, that is transitional influence from environmental tectonic to burial diagenetic control. That is the smectite transformed to be illite. And the elitization here is come as due to the diagenetic process, due to the tectonic and burial diagenetic controls. Also, professional enrichment and depletion of certain chemical, as I said, were noticed. The less mobile titanium, gallium, chrome, and zircon occur in higher amount in the proximal facies, as I said, in the channels, river channels, in the deltaic mouth spa. Whereas the more mobile magnesium, calcium, potassium, and rubidium occur in higher in the distal facies, in the flood plains, and in the distal in the deltaic distal bars, as well as in the lacustrine environment. That is all. Thank you for listening.
Thank you, Dr. Ali, for this informative session. So right now we are going to start our Q&A, question and answer. I will ask the first question. You've mentioned, Dr. Ali, that allocyclic and autocyclic. I don't know. I think it is related to. Is it related to allostratigraphy? So I just want to know, you know, with fine resolution, I just want you to clarify more what the significance of these two terms and how it help to understand it very well, to take a decision and go further.
Yes, allocyclic and autocyclic controls. That is, let me bring the slide to. That is controlled by allocyclic and autocyclic. These control the distribution of the sediments, control the textural maturity. What do you mean by what we mean by allocyclic and autocyclic? Autocyclic within the basin, the factor that within the basin. And allocyclic, that is the factors beyond. That is, as example, auto, that is the current of the river that is within the deposition environment, within the basin, inside the basin. Auto, this is auto. Allo, that is outside. Outside, that is the tectonics factors. Tectonic factors and the depositional environments. That is the environment. The daily deposition environment is outside of the basin. It means auto, within, the factors that working within the basin. That is the value current directions of the river, the value current directions of the lake, the value current directions of the sediment transportation process.
Okay, thank you. My second question is into how much the resolution of these sediments. I've noticed that you are talking about proximal facies and you're talking about distal facies. But I mean, if the deltaic, if I want to discrete the deltaic, we know that there is some part of delta. Can the heavy mineral help me to differentiate or to discrete the delta into, is it a broad delta or is it, you know, I don't know, like channel, yeah, distributed channel, into how much, how can heavy mineral help me to figure out the paleo environment?
Yes, of course, the heavy mineral techniques could serve us to know the textural maturity. That is the reworking effect. If you have a strong reworking effect, you will have the competent heavy minerals like zircon, tourmaline, rutile. That is, the grains will be well rounded due to strong effects. And also, all of these mature sediments only exist within the channels. That is where we have the strong current, where we have the strong reworking. So you will have the concentration of zircon, tourmaline, rutile, much amount within these high textural maturity sediments. This is because whenever you have weaker currents, this of course at the distal part where you have the floodplain of the river or in the mid of the lakes where you have the sediments is more or less not mature. So the reworking effect here is very weak. So you will have the concentration of the selimonite, epidote, hornblende. This is the weak tolerance heavy mineral. So heavy mineral can indicate the source rock, the origin of the sediments, as well as can give us idea about the textural maturity. Where we have the proximal facies, where we can even draw a map for any facies. When we have the result of the webinar, we can even distribute the facies because the indication of the concentration of the strong minerals, the tolerant strong minerals, we find as the proximal area where you have hard current, especially at the periphery of the lake, as example, or in the channel of the river. I hope you get me.
Thank you. There is another question. What type of traps do we have in Muglad Basin?
Traps?
What type of the traps? Yeah. We have a question from Mohammed Usman. He is asking what type of traps do we have in Muglad Basin?
Then we have a structural trap, more or less a structural trap. That is
okay.
We now in the Ministry of Oil, we are looking even for these stratigraphical traps. But as you see, it is more or less difficult to configure this stratigraphical trap, but it is more easier to draw this structural trap that is coming as a result of faults or fault?
Okay, there is another question. The environment of main reservoir is Bantu Formation, which is a braided river environment, as you mentioned. He is asking what are the criteria used to differentiate between the braided river deposit and the meandering river deposit. So there is a good reservoir. I don't know, this is a question, it's look like this.
Yeah. Of course, we have 4 types of river as in the textbook. We have braided river, we have meandering river, we have anastomosing, and we have a straight river. In Sudan, we have more or less this is braided and meandering within deep subsurface facies. As I said, the Bantu Formation is dominated by braided river sequences. And Aradeba in the upper part is dominated by meandering. How can we differentiate between the braided and meandering using this sand mud ratio? Both of them, of course, have produced fining upward sequence, but the amount of sand in the braided river is greater, whereas the amount of mud in the meandering river is greater than the sand. If we can say the sand mud ratio in the braided river is more than 1, whereas in the meandering river is less than 1. If we calculate the thickness of the sand bodies and then divide it by the thickness of the floodplains of the mud stone, we'll find it in the braided river is greater than 1. That is, the sand is greater than the mud. But in the meandering river, the mud is greater than the sand. But both of them are finding upward sequences.
Okay, thank you for clarification. Thank you again, Dr. Ali, for being here with us today in PNA. Actually, and at last, I want to thank everybody for being here with us. And I want to tell you that the session will be uploaded in YouTube as soon as possible. So bye-bye, and till we meet again.
Thank you very much.